Welcome back to the Pneumatics lab. Today, we are building a fully automated multi-cylinder circuit using nothing but the power of compressed air. In this experiment, we will control two double-acting cylinders and a single-acting cylinder using a 5x2 pneumatically piloted directional control valve. How do we control these cylinders without electricity? We use the 5x2 valve as our main switch. It has 5 ports and 2 positions to direct air. Instead of an electrical coil, we use a small burst of air called a pilot signal to push the internal spool and change the valve's position. This sends high-pressure air to extend our double-acting cylinders with full force. Our single-acting cylinder also uses air to extend but relies on a built-in mechanical spring to return to its home position. The secret to this experiment is understanding that compressed air acts as both the muscle and the brain. The main air lines do the heavy lifting while the thinner pilot lines act like a nervous system telling the valves when to shift. The biggest challenge in multi-cylinder pneumatics is avoiding signal overlapping, where 2 pilot signals hit a valve at the same time, causing a jam. Proper sequencing ensures only one signal is active at a time. Before you touch the trainer kit, run through your checklist. First, set your main pressure at the conditioning unit. Second, trace your pilot lines carefully to ensure the correct sequence. Finally, adjust your flow control valves so the cylinders move at a safe, controlled speed. You know the theory, now let's build the circuit.
Hello everyone. So here we can see this is the advanced PLC trainer kit for pneumatics. Why pneumatics? What is exactly pneumatics? Pneumatics is nothing but a compressed air that we take inside and we create some actual tasks. So for example, if we have to consider what is pneumatics in your daily life, you can consider, say, if you have traveled through metros or new electric buses, the door actuation, the door close and open, you hear a sound. That is compressed air. What the door closing and opening function is happening is nothing but pneumatics. That is compressed air, and it is given to certain cylinders or say certain devices, and that exactly comes out, as an output where we can see that is a door open and close. This is the real life example that we see in everyday life.
The trainer gave a great example of metro doors. But why do we use compressed air instead of electrical motors for this? Because pneumatics provide fast, smooth, and highly reliable linear motion. More importantly, compressed air has natural compressibility. If a door traps a passenger, the air acts like a cushion, preventing crushing injuries. It is a built-in safety mechanism.
So I'll explain about the trainer kit, exactly what components are there in this trainer kit. For this, we have the main component is Siemens PLC S7 1200. This is our main Siemens PLC. This is the Profinet cable that is connected to the computer CPU. Through this the communication is happening. This is the main power supply where the power comes to the trainer kit. Okay. These are the digital inputs that we take from the PLC. These are the digital outputs that are PLC outputs. Okay, and these are analog input and outputs. Okay, here we can see that we have connected few blue wires and few red wires. So exactly what is this? This is power supply giving to the other modules. This is the switches module. These are the push buttons. You can see these are the push buttons. Okay, so to give power to these modules, we have done the looping of positive and negative. Okay, these are the double acting cylinders. These are 2 double acting cylinders. This is single acting cylinder which is spring ridden. This is 5x2 directional control valve, solenoid operated. This is the FRL unit, and this is the manifold. Manifold is something that if we need multiple connections, so we cannot connect multiple wires, right? So we have these multiple holes wherein we can take multiple inputs. Okay, so the aim for this experiment is when we connect, when a push button is actuated, or say when one input is given, consider this is my cylinder number A, this is cylinder number B, this is cylinder number C. So what is happening is when I press one push button, my cylinder number A and cylinder number C should move forward, that is they should extend, and when this, and slowly cylinder number B also should extend. In that condition, cylinder number C should retract behind. This is my first condition. My second condition is exactly opposite to what we are doing in condition number A, that is these cylinders should retract behind. Okay, and my third condition is when say push button 3 is pressed, the whole system should stop. It is same kind of an emergency switch. So we'll start doing the connection. So for this we will be needing a few patch cords and one T for the pneumatic connections, and these are the pneumatic wires. Okay, so first we'll do the pneumatic connection. So this is my inlet. I'll be giving, okay, here how you have to give is, you have to just take this cable and insert it, just put it in the hole and press it behind till the wire doesn't go more behind. Okay, and when you have to remove it, you can see here blue, you have to just press it and remove the cable. If you are not pressing it and just pulling the cable, it won't come out. Okay.
The trainer is demonstrating a push to connect fitting. Why must you press the release collar? Inside there are tiny metal teeth holding the tube and a rubber O-ring sealing the air. If you forcefully yank the tube, you will destroy the internal seal. Under high operating pressure, a damaged fitting will cause the tube to violently blow out. Always be gentle with your pneumatic connections.
So you have to press and pull the cable. Okay, so now we'll insert the wire and we'll take one connection from the manifold. Okay, these are my two inputs. So one I'll be giving to cylinder number B and one I'll be giving to cylinder number A. Cylinder number B I have given, this is cylinder number A. Okay, this side will move forward, so it is called as extend. This side will come behind, so it is called as retract. Okay, I'll take my T connection. I'm holding and putting. Okay, so here my pneumatic connection is done. Now we'll do the electrical connection. For electrical connection, we need to give one positive from here and one negative. And here we are using two push buttons. I mean what we say, these are called as toggle switches, or you can call it as push buttons, and here we need to connect the cables. Okay, also in this one thing I would like to mention is you have to follow the word scale standards. That is, initially you have to connect your two cylinders or any number of cylinders that you are using. So the steps will be, you need to connect your cylinders, and then you need to connect your solenoid valves or whatever directional control valves that you are using. And below that, if you are using any manifold, anyways I have connected my manifold here, you can connect anywhere you want. And also if you are using any directional control valves or anything like that, this will come below that. These are the standards that we need to maintain. So these are the toggle switches, okay, or you can call it as push buttons also. And here we need to insert the cables like this, just the patch cords. So what now I am going to do, if I insert my patch cord like this and just directly connect it, will it look good? No, right? So what we are going to do is we are going to route these cables. So how I am going to route is, you can see this cable, you have to hold it like this and just insert it in the slots that are given. Okay, insert the cables, route it accordingly and do the connections. Okay, when I am using two cables, I am just gonna interconnect it like this. I have interconnected this cable, so there is a bottom part and a top part. So I can use my bottom, second wire's bottom as my first wire's top. So like this it is going to be connected. Okay, here also I have done the connection same. Okay, going to connect it. I am going to take my negative, taking this negative as my solenoid's other part as positive, and this I will again give it to my switch number 2. To pull it and connect it here like this. So this is my connection done. Okay, okay, so my connection is done. Have you guys noticed one thing? Is my solenoid an output device or an input device? You can see here I have connected to the input, right? So is it an output device or an input device? It is an output device. It should not be connected to the inputs. My input is only my buttons that we are going to give for actuation. Okay.
Stop right there. Let's clarify this critical concept. A push button provides a simple electrical signal. It is an input device. A solenoid coil requires actual electrical power to create a magnetic field and physically shift a valve. It is an output device. If you wire a load like a solenoid to the PLC's sensitive input module, you risk permanently burning out the internal circuitry of this expensive Siemens PLC. Always separate your inputs from your outputs.
So, do not connect your solenoid to the inputs, connect it to the output. So, let's correct it. Connect it to the output. Okay. So, now my connection is right. On your screen, you can see a PLC ladder diagram. As usual, you have to create a ladder diagram. The logic will be of say AND gate, and there is a emergency stop button. We have named it as emergency stop, but my third condition is that I need to press a button and my entire circuit should stop. So it is nothing but my emergency stop. There are 2 push buttons, 1 emergency stop. So totally we have 3 inputs. Okay. This is what the PLC logic is, and as we do, you have to compile the PLC ladder. You have to download it to your PLC device. You need to check it, and then you need to turn on the trainer kit and check your connection here.
Classic lab mistake. The push button is pressed, the PLC is running, but the cylinders aren't moving. Why? Because the PLC only acts as the brain. You still need the muscle, the compressed air. The main air isolation valve was never turned on. Remember, electrical signals cannot actuate a pneumatic system without physical air pressure. Always verify both your electrical and pneumatic energy sources before testing.
Check our circuit. First you need to give air supply to your FRL unit. So you need to slide this. Okay, you will listen to a sound and you will have the air supply in the circuit. Now we'll press push button number 1. So my what is my condition is this cylinder number A and cylinder number C should move forward. It should extend. Okay, and then later slowly my cylinder number B should extend forward. Okay. Okay, I just have toggled my switch. So we saw that cylinder number A and C first initially extended. Okay, when cylinder number C retracted, slowly my cylinder number B moved forward or extended. Okay, this is my first condition. So we have satisfied our first condition. My second condition is either we can press emergency stop or say stop button and we'll stop the circuit, and then we'll see the next connection. Okay, so this is my next. Okay, I have pressed my emergency stop, so my circuit has stopped here. I'll push my push button number 3. Okay, what was my condition? This will move, this will retract slowly, this also will retract and A will retract. A, B and C, they retracted all behind. Okay, this is the whole condition of this circuit.